Okay, today is January 31st, and we're taking a look at log equations. Okay, this is pretty straightforward stuff. I'm not going to give you an assignment on it, but I'm going to need you to complete the assignment that you went ahead and started on Friday and submit that to Canvas by the end of today. So please complete your log properties accuracy by the end of today. Alright, so here if we go and take a look, we've already seen solving equations that if we have a to the power of b equals a to the power of c, then we can conclude that b has to equal c, right? If the bases match, then the exponents must be equal. We kind of already talked about that. Well, there's something very similar with logs, right? If log base a of b is equal to log base a of c, then we can conclude that since the log bases are the same, again, they both have to be a, that the insides must match. So we can conclude that b equals c. Okay? Now, I'm going to show you this in a way that we don't usually tend to think about it. Okay? So just bear with me on this, right? We have this idea that logs are inverses of exponents, right? So here, if I want to get rid of this a here, what I can do is I can take log base a of the left. Whatever I do to one side, I do to the other side. So I'll take log base a of the right. Now, log base a of a to the b. The log base a and the a cancel. I'm left with b. The log base a and the a cancel on the right, and I'm left with c. Okay? So that's just to show you kind of what's going on here with this idea of logarithms, because that's where we're headed with these when we're trying to solve equations. All right? Now, likewise, this one on the right is a little bit goofy too, right? But if this is log base a of b and I want to get rid of this, what I'm going to do is I'm going to make it an exponent on a comically large a. So this is now a to the log a of b, right? And then same thing over here. I'll make this side an exponent on a comically large a, right? Now likewise, a and log a cancel. I'm left with b. Over here, a, log a cancel. I'm left with c. So that's just kind of how these work, and that's what it's going to look like when we do equations, all right? So let's start with something pretty easy. All right, we're going to go through a couple examples together. All right, so example 1. I've got here that the log of 3x minus 2 is equal to the log of 7. All right, not too bad, nothing too special there. Okay, so if we go ahead and take a look at this, we can see that because the logs match, that 3x minus 2 must equal 7, right? But I'm going to use my little trick here, right? What is the base hiding on this log? Well, it's a common log, so it's a little 10, right? There's a little 10 down there, a little 10 down there. So what I'm going to use a comically large 10 on each side. So this now says 10 to the log base 10 of 3x minus 2. The 10 and the log 10 cancel. I'm left with 3x minus 2. Over on the right, the 10 and the log 10 cancel. I'm left with 7. Now this is an equation I can solve all day, and I just find that x equals 3. All right, so pretty straightforward, not too bad. All right. Now revisiting the problems we did last week, right? I've got 5 to the 2x plus 6 is equal to 5 to the 4x. Okay? Now, what's going to get rid of a 5? Well, I'm going to use log base 5 on each side. Now, this works out nicely because log base 5 of 5 cancels, and I'm left with 2x plus 6. Over here, log base 5 of 5 cancels, and I'm left with 4x. I then go ahead and solve for x, and I find again that x equals 3. Alright, so again, just another straightforward example, nothing too special. Now, where are we headed with this? We're headed to solving problems that are a little bit more challenging, right? So something where we have 3 to the 2x minus 4 is equal to 8. Alright? Now, if we take a look at this problem, there's lots of different ways to solve this. I'm going to show you first the way your textbook shows it and the way most math teachers show it, and then I'm going to show you the way I do it, which is just a little bit different. Alright? What we're taught here in math class usually is if we need to solve this, we try to match the bases. Can I rewrite 8 as a power of 3? No, it doesn't matter how hard I try, I'm never going to get there. Alright? So what I'm going to do is I'm going to take the log of each side, and you can take the common log, the natural log, any log you want. I'm just going to go ahead and take the common log of each side. Okay? Now here, I know because of the common log in my properties, I can pull this exponent down front, right? Remember that's our property there, right? So I can write this as 2x minus 4 times the log of 3 is equal to the log of 8, right? And that's the power of this. When we take the log, we just bring it down front, okay? Now what I can do is I can divide each side by the log of 3, right? And we're going to pause, we're going to look at this right now, right? On the right-hand side, I'm left with log of 8 divided by log of 3. Think about your change of base formula. Think about your change of base formula backwards. This would actually just be log base 3 of 8, okay? Don't worry about that for now, just showing you it would be log base 3 of 8, okay? So now, I just go ahead and keep solving this equation. I've got 2x minus 4 is equal to log of 8 divided by log of 3. I'm going to add 4 to each side, right? And then I'm going to divide each side by 2. It's not a pretty answer, but I'm left with x equals, I'm going to rewrite this as 1/2 log of 8 over log of 3, and then half of 4 is 2. Alright? So not the best answer in the world, but it works. Okay? Now to show you how I would approach this problem. Alright? Again, I don't love this. So I'm going to take the exact same problem, right, but I'm going to do it slightly different. Okay? Now I'm still going to start the same way in that I'm going to take the log of each side, but I'm going to be a little bit more selective. I can choose any log in the world that I want. What log makes sense if this is an exponent with a base of 3? Log base 3. Whatever I do to one side, I do to the other, so it's got to be log base 3 of 8 over here. Now watch what happens. Log base 3 of 3 cancels, and I'm left with 2x minus 4 equals log base 3 of 8. Remember what I said earlier about change of base formula? I could rewrite this as log of 8 over log of 3. Notice it's exactly where I started with this equation too. Alright, I just like the way this way looks. Now I'm going to go ahead and add 4 to each side. I get 2 equals log base 3 of 8 plus 4. I'm going to divide each side by 2. Alright, and I just think that this answer looks neater. So x equals log base 3 of 8 plus 4, the whole thing divided by 2. Alright? Again, no assignment on these problems, but I need you to finish the accuracy assignment from Friday on properties of logs and upload that to Canvas. Alright? Email me if you have questions. Take care.